So question number 1 is, do you know what an inequality is? Unbalanced, that's a good answer. You know what an equality is, right? An equality has an equal sign. So an inequality has something else. That's an example of an inequality symbol. What symbol is that? That's less than. How about this guy? And of course they're cousins. Less than, equal to, greater than, equal to. And everybody's favorite, not equal to. Now we aren't actually going to solve any with not equal to, but we are going to solve some with greater than, less than, not equal to, greater than or equal to, less than or equal to. So let's start off with this one. X is greater than or equal to -1. There are two ways that you can write the solution to this, and I'm going to show you both of them. I'll show you both of the ways you can write the solution. But before we write the solution at all, let's talk about what this is actually asking us to find. X is greater than or equal to -1. So X is a number. So what we're saying here is, I want you to find a number. And the number needs to do what? What does the number need to do? Greater than or equal to -1. So somebody just shout it out. Give me an example of a number that is greater than or equal to -1. Hey, -1. That's a good one. What else you got? Oh, 0. What else? 1. What else? You know what? Let's just keep going until we name them all. After 2, what's the next one? Oh, you forgot 2.5. Oh, you forgot 2.1 also.
About 2/3.
Oh, you forgot that one. Yeah. All right, keep going. Let's just say all of them. Let's write them all down. Yeah, we should write them all down.
Sure.
Literally?
Yeah, could we literally do that?
I don't know.
No.
No, that'd be really easy. Writing numbers is easy.
Take it all in.
Writing down all those numbers in your lifetime, hard. I'm gonna say impossible to do that. Why?
You do a number.
Why is it impossible? Yeah, because it goes forever. The numbers that are bigger than -1, that's like a lot of numbers, you guys. It's impossible for us to write all those numbers. So we got to kind of cheat when we write all those numbers. One of the ways we cheat is by using something called a number line. A number line. And a number line looks like this. It is a line with numbers on it. I'm going to put the -1 in the middle because that's the number in this problem. That means below -1 is -2, -3, -4, and above this is 0, 1, 2, 3. Now I want to mark on this number line in some way that I am talking about all of the numbers that are -1 and up. So here's how I do that. I'm going to put a bracket right here. Now that bracket right there signifies two things. One of the things that bracket signifies is that -1 is the lowest number I will have in my set of numbers. The bracket means include -1. So this is just the number -1. Now the way I say -1 and up is that on top of this number line, I draw, if you're using all pencil, just do a really thick line. Just like that. What does the arrow on the end mean? It means it keeps going. From -1, 0, 1, 2, 3, 4 to infinity, and the line means all the numbers in between. The other way you can write this answer is in something called interval notation. Interval notation is how you write the answer without a number line. It looks like this. We still do our bracket, only instead of a number line, just inside the bracket, we put our number -1. We put a comma, and then we put the highest number in our range. Now our range was -1, 0, 1, 2, 3, 4, etc. What's the highest that ever goes? You said infinity, right? Infinity there.
Oh, literally?
Literally infinity.
Well, that odd rate.
Huh? So the bracket here means including -1. We include the number -1. We don't want to include the number infinity, and the reason we don't want to include the number infinity is because, I hope this doesn't break anybody's heart, infinity is not a number. So instead of a bracket on infinity, we put that parenthesis. That means not including infinity. So what would be different about this problem if instead of greater than, it was less than, and we don't put the equal to on it? Now what's different about this problem? Okay, so first we'll do the number line. Put -1 in the middle, which means below that is -2, -3, -4, and above that is 0, 1. So x is less than -1 means, what are my numbers? Is -1 one of my numbers? No, because it doesn't equal -1. So what are my numbers? -2, -3, -4. So from the 1 right here, -1, all the numbers lower than that, but not including -1. How did we write that we didn't want to include a number? With the parenthesis, right? So that's what I'm going to do. I'm going to put a parenthesis on the -1, like that. And then my arrow is going to go this direction, all the numbers lower than -1.
You know, it was a bracket, this was a parenthesis.
Parenthesis because this one did not have the equal to line, and this one did. Brackets when it equals, parentheses when it doesn't. So if I was going to write this in interval notation, this is what I would do. What is the lowest possible number I can have in my range here? -infinity, comma, what is the highest possible number I could have in my range? I can't actually have -1. I can have the number just below -1. So here's what I'm going to do. I'm going to write -1, and then I'm going to put parentheses. What this means is just right below -1, but not -1. Now here's why that's important. I could have -2, but what about -1.5? That would be right there, right? -1.5 would be in my range. That'd be okay. What about -1.4 or 1.3 or 1.2 or 1.1 or 1.01 or 1.000001? Anything lower than -1's okay. Rather than worry about like what's the biggest number that's below -1, I just do the parenthesis right there. And the parenthesis says everything up to -1 but not -1. Now where these get a little tricky is like this. What if I got to solve it first? Huh? Oh, this is not a lot more work. Don't be a whiner. I'm still going to solve this just like I've solved every other problem. I'm going to subtract 4 on both sides. I want to get x by itself. I'm going to subtract 4 on both sides. X is less than or equal to -10. It's not any different from an equation. Just a different symbol in the middle. But calm down, everybody. It's going to be okay. All right, so let's do my number line. This time my number is -10, so I'm going to put that in the middle. Like that. x is less than or equal to negative 10, what are the numbers that would work there? Negative 10 could be one of them, right? And then everything lower than negative 10. So what are those numbers that are lower than negative 10? Negative 11, negative 12, negative 13. So here's what I'm going to do. I'm going to start at negative 10 and go all the way down. Would I have a bracket or a parenthesis on negative 10? Bracket, because it could be negative 10. Good. And then arrow going like this. In interval notation, what's the lowest it could be? Negative infinity. What's the highest it could be? Negative 10. I always put a parenthesis on the infinity and negative infinity because you can never equal infinity. What about on the negative 10 though? That's a bracket. Man, this does not seem bad at all. Okay, so I appreciate that you think I'm going to make it bad. It shows that you have strong pattern recognition, and I appreciate that. But actually, the worst part of these, in my opinion, is remembering this one little rule. You might even remember this rule from grade school. Way back when you learned these, back in the dark ages. What would I do to solve this one? Divide by negative 2. What happens when you divide by a negative?
Multiplies.
Anytime you change the signs, meaning this was a negative and now it's become a positive. This was a negative 4, now it's become a positive number because I divided by a negative. Anytime the signs change, the symbol has to flip.
Flip, you said?
Like that. When signs change, and this only happens when you multiply or divide by a negative. Multiply or divide by a negative. Reverse the inequality. As Abraham Lincoln once said, put your thing down, flip it, and reverse it. Flip the inequality. As Napoleon Bonaparte once said, when a problem comes along, you must flip it. No, you know, it's misattributed to Devo, but Napoleon, actually the first. So on the number line, what do I do? Where do I put my mark, and what is the mark? It's on 2, bracket or parenthesis. And will I be highlighting the numbers higher than 2 or lower than 2? Higher, because it's greater than 2. So bracket on 2, greater than 2. In interval notation, what's the lowest it could possibly be? What's the highest it could possibly be? Bracket or parenthesis on 2? Bracket or parenthesis on infinity? There we go. 2 ways to display your answer. Now, don't make the mistake that so many math students that have come before you have made. See if you make the mistake. What do I do first here? Divide 2. So that gives me x, gives me negative 2. Do I flip the sign?
No.
Why not? Yeah, because I didn't divide by a negative, so the sign stays the same. Don't make that mistake. The sign doesn't flip when it's a negative. The sign flips when you divide by a negative. Negatives are fine. It's dividing by a negative that's bad. So where do I put my mark?
-2.
-2. And what am I doing?
You're going to do a bracket.
Is it equal to 2? -2? Is it equal? No?
Greater. Oh, less than.
It's less than -2, and it's not equal to. So it's a parenthesis on -2, and then all the numbers that are lower than -2. So parenthesis on 2, and everything lower than -2. Okay. So what's the lowest it could possibly be? What's the highest it could possibly be? Bracket or parenthesis on -infinity. Bracket or parenthesis on -2. Nailed it. Yes. Rock on. That's the appropriate reaction. Rock on indeed. I like to rock on, as the cool kids say. I know how to rock. All right. I'm gonna rock and roll all night up till 9 p.m. That's when I'm tuckered out at 9 p.m. So I want to rock and roll until it gets dark outside. And then I'll get up early and continue partying the next day. But I need 8, maybe 9 hours of sleep a night, or I'm totally useless.
Is that a 7?
Are you, like, criticizing my handwriting?
No, I'm just making sure.
It's a 7. It's pretty messed up. They're also rocking all night. What do I do?
I would say -7.
I would also say minus the 7, so that's pretty good advice. Normally, agreeing with me is cause for concern, but in this case, you're on the right track. Divide by -4. We're dividing by a negative. What does that mean? It's going to be positive, which means
Oh, it flips the
reverse the inequality symbol. X is less than or equal to 4. All right, let's do our number line. I'm putting my mark on 4, yeah?
Yep.
Bracket or parenthesis? Bracket, because it equals 4. Going up or going down? Going down. So what would it look like in interval notation?
bracket.
The lowest number is -infinity, and the highest number is 4. Always a parenthesis on -infinity. Bracket on. Right, we're going to do just 2 more problems. I want to show you kind of the worst that these get. And the worst that they get, it has nothing to do with the inequalities and everything to do with the algebra. The worst they get is when you have x's on both sides, like this one. They don't get a lot worse than this. So if you treat that inequality symbol like it is an equal sign, you are going to be in good shape. Pretty much every single part of these can be done just like that is an equal sign, except if you ever divide by a negative, you have to flip the symbol. Other than that, this functions exactly like an equal sign. So with that in mind, what should we do first?
The group.
The distributive property, I agree. Let's do that. So negative 5x plus 7 is less than 2x minus 2 times 3 is 6.
So does it matter which one, like which side it's on? The X?
So the question was, does it matter which side the x ends up on? And the answer is not at first, but eventually we do want the x to be on this side and the number to be on this side. If the x is over here and then we flip it later, that's totally fine.
Like
We
the,
do -2.
Yeah, I mean, let's talk about what the implications of that are. If I add 5x to this side, I won't have to deal with negatives, but the x will be on the wrong side, which means at the end I'll have to flip it. So the x is on the right side. If I instead subtract 2x on both sides, then I'll have a negative number here, which means when I divide, I'll have to flip it.
Yeah.
So I'm flipping it either way. So it's down to personal preference. I think I'd probably subtract the 2x myself, just so at least the x's are on the right side. I mean, the correct side. That's what it would look like after we did that. If you added the 5x instead, that's totally fine. Not a problem.
You take your
Now what should we do?
-7.
Let's minus the 7. That's a good idea. Which gives us negative 7x is less than negative 13. Then what?
Division.
Divide by negative 7. When we divide by a negative, what happens? So instead of less than, it's greater than. Negative 13 divided by negative 7 does not come out to be a real nice whole number. It's a negative divided by a negative, so it's positive, but 13 divided by 7 is just 13 sevenths.
Two negative is positive.
Yep, negative divided by a negative is positive. Which is why if somebody says something mean to you, you should say something mean back, because 2 negatives make a positive. It's my life advice for you. Somebody torches you on social media, you torch them back because that makes it positive. And if somebody says something positive, you say something positive back because a positive times a positive is also positive. If people just paid more attention to math, the internet would be such a nice place. Two rights do not make a wrong. Two wrongs do not make a right. But 2 negatives do make a positive. Last one.
Groups.
Yep, let's do some distributive property. That seems like a good idea. There's a lot of distributive property. Really not feeling super excited about this, but here we go. 2 times x is 2x. 2 times negative 3 is negative 6 minus 5. Okay, left side done. 3 times x and 3 times 2 minus 18. Remember, we do not distribute the minus 5 on the left side. We don't distribute the minus 18 on the right side because those are not being multiplied by the parentheses. Okay, cool. So we got rid of our parentheses. That feels like a good thing to do. Now what?
X is on the one side.
I could collect the x's on one side, but first I'm going to combine the other numbers. Exactly right. So let's do that.
So -6 minus
If I combine those two, that's going to give me 2x minus 11. And then over here, I'm going to combine those two minus 12. And again, you have a decision to make. I need to collect the x's together on one side. If I subtract 3x on both sides, I'm going to end up with a negative, which means I will have to flip this symbol at some point, which is not a big deal. If I subtract 2x on both sides, I'll have a positive x, but it'll be on the right side instead of the left, so I'll have to flip the symbol, which is not a big deal. I think it's faster to just keep the x's over on the left side. That's my advice. Take it or leave it. You'll get the right answer no matter what you do. So it doesn't matter. In this case, my advice is worth what you pay for it. You'll come out okay either way. Now what? Let's add the 11. That seems good. Huh? We will have to flip the sign after this step, because what's this step going to be? Divide by what? Divide by -1. Very good. X and +1, and this will be greater than or equal to. I think we forgot to actually write the answer on the last one that we did, so let's make sure we write the answer on this one. Let's just write it in an interval notation. What's the lowest we could possibly have here?
Oh,
One's the lowest we could have. What's the highest we could have?
infinite.
Infinity. Brackets or parentheses? Yeah, where? That's a good question. Parenthesis where? Parenthesis on infinity always, and the bracket on the 1. Does anyone have any questions about inequalities?